Hello friends. So I hope all of you are doing great today. So in the previous session we have actually done a little bit of understanding on short circuit transients. So short circuit is a condition which is the most severe condition which can happen in the generator. And what is the most severe condition that can happen in a society? It is very violent protest, right? So recently, I think yesterday there was quite a violent protest here in Mumbai. So that is something associated with the society, but which is very harmful for the society, and it is not good for the society as well, because most of the people which I saw were the young people of the country, around 17, 18, maximum 23 years, 24 years old people were actually taking away people from bus, stopping the bus. And today morning when I saw, around 4 signals were destroyed in our locality. All the 4 signals were destroyed, and already because of rains the roads are having a bad condition, which made reaching the office quite a difficult task for me. Okay, so that is about the society. I just got deviated a little bit. But for a generator, the most severe condition is the short circuit at its terminals. So we saw that this was the AC component of that current, and you can divide it into 3 sections. One is the subtransient component, then is the transient component, and the steady state component. So subtransient component, I told you that it will have a less value of time constant, therefore it will decay very fast. Transient component at a higher value of time constant, it will decay very slow. And then finally this is the steady state short circuit current. Okay, so today let us do a simple numerical on that. So what do you have here? We are having a 100 MVA generator. It's a very big generator, right? So it is 13.5 kV of voltage it can supply, and it's a star connected generator, therefore IL will be equal to I phase. It is 60 Hz generator and is operating at rated voltage and no load when a 3-phase fault develops at its terminals. Okay, so what they are telling is that this is the generator. So let me just draw the per phase equivalent here. So it was supplying no load condition. So but what happened was that due to some condition there became a short circuit. So if this was the generator, this is the dead short circuit which has happened across its terminals. Okay, so what are the things they have given? The terminal the reactances per unit according to the machine's own base, xs is equal to 1, x dash is equal to 0.25 and x double dash is equal to 0.1. Now you might be wondering why these are not in ohms. Now this is the concept of per unit. Okay, this is more depth understood when you learn power system stability. So anyway, per unit is equal to the actual value divided by the base value. Okay, this is a standard practice which is used and very advantageous in electrical power systems. So we'll just see a little bit about that. And what they have given is that the time constants they have given. So T dash is equal to 1.10 seconds and T double dash is 0.04 seconds. So out of this, which one will be the subtransient time constant? Naturally this will be the T double dash will be the subtransient component, because this is a lower value, and T dash is a higher value, therefore it will be the transient time constant. So another information is the initial DC component averages 50% of the initial AC component. So I told you initially there is a DC component also like this. So they are telling that this average value of this DC component is 50% of the AC component. Okay, so this is what they have given in the question. So what all they are asking? What is the AC component in the generator after the fault occurs? So you have to find the value of the AC component just after the fault occurs. Okay, so basically what they are asking is that they are asking you to find the subtransient current. Okay, so let us see how we can find it now. So before that, let me just write down the ratings what all they are given. So they have given it to be a 100 MVA generator, right? All these ratings is a separate topic and I will definitely take it. It's a very interesting topic. And this is 13.5 kV generator. Okay. Now in per unit concepts, we have to assume 2 of the quantities as base quantity, and the third quantity you have to find from these 2 base values. So let us take these 2 quantities, that is the apparent power and the voltage, as the base quantity. Therefore the line current base, IL base, will be equal to how much? It will be the apparent power divided by √3 into VL, right? So the apparent power is 100 MVA, so divided by √3 into 13.5. Okay, kV. So just to make the units proper, I have to convert this MVA into kVA. So I'll multiply it by 10 cube So this will become kVA. So kV will go. So finally you will get the current in amperes. So if we find out this value, this will come around 4277 amperes. Now in Chapman, there is a small printing error. They have given in the question it is 13.5 and here they have calculated it for 13.8 and they have found out different current values. So what you can do is that you can just correct this value for 13.8 kV. You can write this question itself as 13.8 kV and proceed with the solution. But what I did was I took the 13.5 kV itself and I proceeded with the solution. So this is the IL base value. Now first question is to find the subtransient current, right? So subtransient current, you know that it is I double dash, which is equal to EA divided by X double dash, right? Now because I have taken the base value as the voltage itself, so EA itself is a base value. Okay, EA itself is a base value. So EA per unit value will be equal to actual value divided by base value. Since EA itself is the base value, so EA divided by EA will be 1.0. So this will be equal to 1.0 divided by, and what is X double dash they have given? X double dash is 0.12, right? So X double dash is 0.12 and this will give you 8.33 per unit. Okay, so this is per unit value of current. So what is the actual value of current? The actual per unit value is equal to actual value divided by base value. So actual value will be per unit multiplied by the base value. So I double dash actual will be equal to 8.33 into the base value. So here we have already found out the base value. So this is why we found out the base value here. So it is 4277 amperes. 4277. So this value will give you around 35627.4 amperes. Now I have already calculated it using my calculator. But as I always tell, you should do this entire thing on your own without looking the videos once. Okay, you see the videos, understand the solution, then attempt to do the solutions on your own. Then only you will understand the concepts. Okay. Now, just because we have now found out I double dash, so this part of the question is actually over. But let me just find I dash also, because that also will be useful. So EA PU divided by X dash, right? So this will be equal to 1.0 divided by, what is the transient reactance? Transient reactance is given to be 0.25, right? Transient reactance is given to be 0.25 and this will be equal to 4.0 per unit. Okay, so the actual value of the transient current will be equal to 4 multiplied by 4277. Okay, base value will be the same for everything. It is the per unit value which you are changing. So actual value is per unit value multiplied by base value and this is 17108 amperes. Okay, so this is also there. Now what is the steady state short circuit current? Okay, so that will be EA per unit divided by XS, right? Now XS value is given to be 1 per unit. Okay, so that is also there. So this 1.0 by 1.0, that is equal to 1 per unit, and therefore ISS actual, short circuit current actual will be equal to 1.0 multiplied by 4277, which is equal to 4277 amperes. Okay, so this much is the steady state short circuit current. Okay, so we have found out all the currents. Even though they have asked only this, we have found out all the currents. So what is the second part of the question? Second part of the question is, what is the total current, okay, which is the AC plus DC just right after the fault occurs. Okay, you know that there is a DC component and an AC component. AC component we have already found out in the first part. So they are asking what is the DC component. Now you have to see what is the information they have given in the question, because other than that there is no information given to find the DC value. So they are telling that the initial DC component averages 50% of the initial AC component. Okay, so that means the I total, what they are asking, okay, in this question I total will be equal to the subtransient current I dash plus IDC, right? And they have given IDC is equal to 50% of I double dash, okay, initial AC component. So this will be equal to 0.5 I double dash. So if I substitute that value here, I will get it to be 1.5 I double dash. 1 plus 0.5 I double dash, which is equal to 1.5 I double dash. So this value will be 1.5 into I double dash, which is this value, into 35627.4 amperes. This will be a huge value, 53441.1 ampere. Okay, so this is the initial amount of current, and as time goes this will gradually decay and finally you will reach the steady state short circuit current, and that is what is shown in the next part. What will be the AC component after 2 cycles? What they are asking is that this third part of the question, what is the AC component after 2 cycles, okay, and after 5 seconds. So when you see such an equation, you will have to have a time based equation, which we have already seen here. So this is with respect to time, okay, this value is with respect to time, okay. So we will just write down that general equation, that is the I of t will be equal to I double dash minus I dash. We did the derivation in the last session, e power minus t by t double dash plus I dash minus ISS into e power minus t divided by t dash plus ISS. So this is the equation based on the time. So what they are asking is that what is the I of t after 2 cycles? 2 cycles. Now when the word cycles come, naturally it is dependent on frequency. So what is the frequency? The frequency is 60 Hertz. So then what is the time period? It is 1 by 60, right? So what they are asking is that the frequency, so this is 1 by 60, right? This is the time period, which is 1 by 60. So they are asking after 2 cycles, how much is the current? Okay, after 2 cycles means 1 by 60 plus 1 by 60. So that will be equal to 2 by 60. So the time period for 2 cycles will be equal to 2 by 60, which is equal to 1 by 30 seconds. Okay, so we have to substitute, we have to find the value of I at 1 by 30 seconds. Okay, so we'll substitute all these values here now. So we will get different values we'll have to take from here. So I double dash is equal to 35627. I will just write that equation here, okay, so that I don't have to go anywhere. So it is equal to I double dash minus I dash e power minus t by t double dash. I'll just quickly write it. So I dash minus ISS into e power minus t by t dash plus IS. This is the equation, right, which you have written in the previous page. So I double dash value is 35627.4 minus this value, right, 17108 into e power minus t divided by t double dash. So what is t double dash value given? T double dash value is given to be 0.04 seconds. So this value, you can see it will decay very fastly, because 1 by 0.04, which will become the decay value, is very high. So plus, next is this component here, right? So that is I dash 17108 minus ISS. So 4277 into e power minus t divided by, I think t dash is 1.1 seconds. Yeah. So t dash is 1.1 seconds plus 4277. So this is the time based equation. So this we'll copy to the next page. It is not getting copied. Yeah. Copy. We'll paste it here. Yeah. Okay. So this is the equation. So this is not, this is for, this is actually I of t. So I at 1 by 30 seconds will be equal to, for t you have to substitute I is equal to 1 by 30. So this will be 18116 approximate value into e power minus 1 by 30 divided by 0.04 plus 12552. If you have any, just do it with your calculators, and if there is any change, put it in the comments below. Right? I did my own calculation. I don't know if there is any mistake in there, but till here the concepts are pretty correct. So this is e power minus 1 by 30 divided by 1.11 plus 4277. Okay, and you have to find this value. This value will come around some 25,000 amperes or something like that. So you find out this value and tell me it in the comments below, because you also have to do some work, right? I cannot do everything here. Yeah. So next is the next part of that question was to find the after 5 seconds, right? After 5 seconds, what is the value? So it is nothing. So I at 5 seconds. So at I at 5 seconds for t here, just like you substituted 1 by 30, you have to substitute 5 seconds. So that value will be very close to this value 4277, because this is the steady state short circuit current, and 5 seconds is a large enough time for the subtransient component to decay and the transient component to decay, and finally reach its steady state value. So if you find that value, you will find that it is very close to the steady state short circuit current. Okay, so this was a simple numerical to understand this concept of short circuit transients. And now for synchronous generator, there are around 2 or 3 topics remaining. One is the rating of the synchronous generator, how synchronous generators are rated, like voltage, current, frequency, and apparent power. All these things we will cover in about 2 lectures. And after that, there is a important concept on limits. Okay, on limits of operation of synchronous generator, which every operator has to follow. So that is also an important topic. That also will take 2 lectures. So around with 4 lectures, we will be completing synchronous generators and we will move on to synchronous motors. So I will try to upload it as soon as possible so that it will be beneficial for you. So if you will like this video, please like, share and subscribe the channel. Don't forget to watch the other courses like DC machines, AC machinery fundamentals, and engineering circuit analysis, which are present in the same channel. So before going, I would like to tell that India is a country which has the largest amount of the young population. Okay, no other country has this benefit. And in other countries, in a few years, there will be a shortage of young people. That means there is going to be a huge growth market, job market for skilled workers. Remember that. People from other countries, already Japan is already facing that issue where old people are higher in number in population as compared to young people. In all those countries, there will be a requirement of young skilled workers. Okay. So in our country, we are having enough young people, but it depends upon the government policy and personal things, personal interest, that whether you want to become a skilled employee or an unskilled employee. Remember, a skilled youth is always an asset for a nation, but an unskilled youth is always a burden for a nation. So please remember that nobody is going to support you throughout your life. All the things which you are going to enjoy is just temporary. Every decision that you are going to make at this point of time, the hard work which you are going to put in your life, that is only going to bring you forward. So therefore, don't get distracted by unwanted antisocial activities. It is my request from my side. If your friends are doing all these things, please stop them. Okay, please stop them. Ask them not to do all these things. Concentrate on their studies. Make your parents proud. Make your community proud. Make your society proud. And make your country proud of yourself. So the choice is up to you, whether you want to become an asset or whether you want to become a burden. Okay, with that I would like to close today's session. So till I see you in the next video, it's me Varun signing off, and have a great day. Thank you.